Greetings, fellow humans. So in a previous video, I showed you how to download somebody's Instagram account and use facial recognition in Python to pull all of the images of that individual into a data set that you can use for SDXL LoRA training. So today I'm going to basically pick up where I left off on that one. I've created a GitHub repository with a bunch of scripts in it, and you're basically going to run them all in alphabetical order. The first script you run creates all of the directories that we're going to need to basically create our build files here. And then what you're going to want to do is take all of your source images and throw them into the raw directory. That'll get us started here. So now the first script that we're going to run is going to basically iterate through our raw directory, and it's going to identify all of the faces and all of the images, crop them down to just the faces, and deposit those as files here into the faces directory. I'm going to basically cut out a lot of the processing time. You can watch the clock there on the lower left-hand corner. If you're unsure whether or not I've cut some time out of the video here, but basically now that we've extracted all of our faces, we're going to index them, and we're going to run the index all script here, which is literally going to compare every single image to every single other image, and the ones that are similar to each other, it'll create a cross-reference in the file. So ultimately, it's going to create a whole bunch of index files, and the biggest file has the most matches with other images, basically. Once we've got our index files, we now have the ability to pull together a subset of the images that represents the data set as a whole. So that's what we're going to do here. We're going to move the index, the matches, if you will, the images into the good directory here. And basically, this is an image for every group of images. So all the images that are similar are represented by a single image here. And what we're going to do is we're going to just go through real quick and find all of the images that are not of our subject, and we're going to delete those images. Let's go ahead and run our final step, and that's basically going to use the set of good images that we've identified that are all of our subject, and it's going to pull the similar images to that good subset into the two directories that we've created here, the body directory and the face directory. And basically the difference there is the face directory is cropped close in to the face, and the body directory is the largest image that we could extract from the source image that is basically just constrained to the subject's body. And so we've got two sets of pretty much the exact same images, but cropped to different dimensions. And so the combination of those two data sets will provide the images that we need in order to train our LoRA. So we're going through now, and in both you're not going to find a whole lot of bad images in the face directory, but you will find a handful of images maybe where an extra face slips through. You're definitely going to have to look a lot closer at the body directory in terms of eliminating bad images. But honestly, if you're in a hurry, it's much more important that when we're pruning the good directory, that you get all of the non-subject images out at that stage. The prepare data set stage, the error rate is really low enough that if you're in a hurry, you can train off of it. But you're going to find a handful of images that you're better off without. So now that we've pruned our data set, our image set to the good body and face images, let's go ahead and train up our LoRA here in the Koya SS GUI. So the first thing we're going to want to do is we're going to want to tag our images. We're going to use the WD14 captioning utility here in the Koya SS. Basically just paste in the path to your directory. I like to create a trigger word, a prefix. Choose something that's not in the dictionary, so to speak, and then you can use that to trigger your LoRA when in your prompt when you're generating. So here we're going through and tagging all the faces. Do the same thing for the body, and then once we've got all of our caption files in place, we'll be able to go ahead and do our actual training. Now, if you're like me, you've already watched a whole bunch of videos on how to train LoRA, and you're still none the wiser. I've got no wisdom to impart, other than use the defaults. Like, unless it doesn't work, don't change it. I don't know. Like, people swear by different things. It makes no sense to me. But what I do for no reason other than it seems to produce results that are reproducible, I target about 7,000 steps. Since I've got two folders here, we're going to put about 3,500 in each. There's 212 in the one and 302 in the other. And if you do this step before you tag your images, you can get away with doing less math. All right, now that we have indicated how many repetitions we want to do of each set of images, let's go through and finish setting up our LoRA for training. First things first, we're going to choose a custom model. The SDXL model is not yet in the list of quick picks, so I'm going to go over to my automatic 1111 directory and grab the SDXL VAE fix 1.0 safe tensors out of there. So, all right, check the SDXL box. Now we're going to paste in the path to our image folder, to our model folder, to our log folder, and we're going to name our model HJXL01. Cool. Now, in terms of parameters, again, I just leave everything at the default until someone can show me some definitive proof that any of these things do anything. I'm not going to futz with it, but in the last video I did fail to set the .txt for the caption file extension, and that will impact your training, I promise. All right, I'm going to go ahead and fire this off. It's going to take about 3 hours in total to train. We're doing 3 epochs, and we're doing about 7,000 steps per epoch. And with my graphics card, that takes about 3 hours. So here we are processing the latents. Take a few seconds to burn through all of those. And then once we've finished caching our latents, it's going to tell us how many hours it's going to take to build our LoRA. And then basically I'm going to pull a Martha Stewart on y'all, and I'm going to take this half-baked mess that I've got here and set it aside and pull out the beautiful pie that I've got in the oven. Here you are. Take a look at our results. We've got a gorgeous little SDXL01 safe tensors. We're going to throw that into our automatic 1111 model/LoRa folder. And we're going to fire up our automatic 1111 and give our brand new LoRa a spin. Let me know in the comments if you'd like to see a video on some of those LoRa training parameters that I was mocking just a moment ago. I'd be happy to go into some of those in depth. Or even better, let me know in the comments which parameters you find indispensable and what values you use. All right. Speaking of values that I picked for no apparent reason, I used 32 sampling steps. You do kind of have to use 1024 or somewhere thereabouts for your width and height. I like to choose a batch size of 6 because that gives me a pretty good indication of where the model's at. Any one image could randomly be better or worse than average, but 6 of them will pretty much give you a clue. So here's what we've got, and I think it's pretty good. There's always room for improvement, and again, I'd love to hear your suggestions. Thanks so much for watching, and I'll catch you next time. Cheers.